Hey guys, welcome back to lesson 2.7 about analyzing linear graphs. Today's going to be a pretty short lesson. We're going to be talking about why graphs make sense. And you won't have a quiz or a homework assignment over this one. This is just to help us understand why graphs look the way they do. So we're going to analyze some linear graphs using Desmos. So we're going to graph, I don't know what's going on down there. We're going to graph a linear function. So we're just going to graph basic y equals x. And a couple things we want to talk about right here. One of them is, if you notice, this graph looks like this. We know we have a y-intercept at the origin, a slope of 1. But you might be asking yourself, why is it that the graph looks like this? Well, if I click any point on this graph, if it'll let me click any point on this graph, what these points mean, and if I slide along the graph, every single one of these points, what it shows me is I have an input value. So I have an input value of 1.4, and well, whatever my input value is, I put a value into the function and I get out another value. So the x coordinate is the input value to the function. The y coordinate is the output value for the function. So the reason that the function looks the way it does, the reason the graph looks the way it does, is because it's the infinite set of points that satisfy this equation right here. So we also want to talk about what would happen if we tried to transform a linear graph. So couple ways that we're going to do that. First, we're going to look at transforming it in the x direction. So let's say that's x minus 2. If you notice what happens, technically what happens is I shift the graph 2 units to the right. I can also see that in where the y-intercept went. The y-intercept went down here to 0, -2, because the parentheses right here really, they don't matter because it's just this one statement over here. So really what this did is it moved the y-intercept down to 2. But technically with a transformation like this, what it did is I moved the graph right 2 units. So now let's take a look at doing something like +1. So now what I did is I moved the graph up 1 unit. So this transformation, I moved the graph right 2 units and up 1 unit. And if I put it all together, if I were to simplify this expression, this is just y equals x minus 1. It's the same function. But what I've done here with the transformations, we're going to talk more about graphical transformations with all different kinds of functions that we look at. This moves the graph right 2 units and up 1 unit. So another thing that I want to look at, so I'm going to go back to the graph y equals x. I want to look at how to stretch or compress the graph. So let's say that I have 1/2. So y equals 1/2 x. So one thing that I realized going back to look at some of the other videos, I didn't do a good job of explaining what happens if the slope is a fraction. So we want to think back to the definition of the slope. And the definition of the slope tells us that every time the input increases by 1, the output, in this case, will increase because it's positive by 1/2. So I can actually see that right here as going right 1 unit and then I go up 1/2 of a unit. But I could also think of this as if I continue that same idea of a ratio between the change in y and change in x. What this means is that every time the y value changes by 1, then the x value is going to change by 2. And in this case, they're both increasing because it's a positive slope. So I can also see that on the graph by going right 2 units. So I go right 2 units because my x value is increasing by 2, and then my y value will increase by 1. So I go right 2, up 1, and then that's how I can find the slope of this line right here. So what this does, this is actually a vertical or a horizontal compression of the graph. In this case, horizontally and vertical are both kind of the same thing. But what's happening here is I've taken the graph of y equals x and I have compressed it so that any term that was here is now 1/2 of what it was initially. So any y value on this line, this red line, is 1/2 of the corresponding y value on the blue line. Which makes sense when you look at the rule for the function. So that's really it for today, guys. It was just kind of showing you why graphs make sense, why they look the way they do. One big takeaway that you need to take away from this lesson is that graphs are an infinite collection of points that satisfy whatever the function is, satisfy the relationship given by the function. So if you have any questions, bring them to class. Hope you took some good notes. I hope you have a great day, and I'll see you again next time.